Hello everyone. In this video, we will discuss an introduction about neural networks. Of course, we are not going to dive into the concept of biology, but we will discuss very basic concept of neural networks. And in the following video, we will discuss about the applications, or you can say the implementation of neural networks in the field of artificial intelligence, and that we would be calling as artificial neural networks. So before I start, I need to discuss what is the requirement of neural networks towards computer science or artificial intelligence. We can have one or two reasons or one or two justifications in the answer of this question. First one is, let's suppose uh, what is the actual definition of artificial intelligence. So according to some books or some web sources, we can conclude that artificial intelligence is the practice which at the current time humans do better than computers. So if we want to emulate, if we want computers to do that activity or that practice, then we call that particular phenomena as artificial intelligence. So now we have to distinguish between the activities which computers do better or the activities which humans do better than computers. Then we would come to know that why actually we require the concept of neural networks. Then now second thing, in the context of the definition which I just quoted, let us suppose we have to calculate the power of 10 to any number. For example, 5 raised to the power 10 or 6 raised to the power 10 or any power to any number. Then in such scenario, we all know that the computer would do better than a human. Now, on contrary, suppose if I have to, or if we meet to a particular person after a number of years, let's say, suppose after 5 years, then in such case, our mind recognizes that person in a matter of seconds. But in such case, the computers cannot be that much efficient. How? Because the computer to perform this task would require to match the face of that person with the available images in its database or in its repository or in its storage, and that face should exactly match to one of those images. In case that face would not match to at least one of those images, the computer will not be able to recognize that person in conventional way, if we working in a conventional way. So in such cases, because of course I'm coming back to the definition of artificial intelligence, where we just discussed that the tasks, the activities which humans do better. So in such cases, if we want to make the computers uh, to perform the activity of recognition of a person, so then we require the process by which the computer can work, which is similar to the process of human brain. So that's why the requirement of neural networks exist. So now we are coming to the introduction part of neural networks. So first of all, it is a complex network of simple computing elements, and these computing elements are called as neurons. So like in the digital computers and the conventional computers, we have processing elements in the form of, say, logic gates. So similar to those, in neural networks we have neurons which perform the computing of the data. Now, these neurons are capable of learning from examples through appropriate methods. So we all know that how human brain is capable of learning. Suppose in the last video we also discussed the example of a kid of a child where he or she learns that this animal can be a dog or can be a cat with a view to its body structure. Means it has four legs, its face is something like this, then the child can decide whether it is a dog or cat. Similarly, suppose now if we talk about another person or a boy or a growing child, then for example, if a child with his or her father or mother is trying to cross a road, and then from a particular side a motorcycle comes, then the guardian stops the child to cross the road because it may lead to an accident. Now, in the next time when a car comes, the child would be understanding that it may also be the dangerous thing to cross the road. So, this is the learning process acquired by human brain. The neural networks follow connectionist approach to computation. Means these neurons are connected together, or the processing of data, the solution of a problem is done by following a connectionist approach. Means the tasks are distributed among the neurons and then connected. Those connected neurons can simultaneously find out the solution. Okay, in one of the upcoming slides we will discuss the uh, difference between digital computers and neural networks, and you will see that the actual processing speed of neuron as compared to the digital computer is slow, but since they work simultaneously or follow the connectionist approach, that's the way they perform quite better than the digital computers. Now you can see the biological structure of a neuron, and we will discuss the important parts of this structure. So first one is soma. It is the body of the cell. Then we have dendrite. Dendrite is defined as the incoming branch. Means the incoming branch from other neurons is called as dendrite. Opposite to dendrite, we have axon, which is an outgoing branch out of a neuron. And then we have terminal buttons, which are also called as synapses. So these are the junctions between axons and dendrites. So between two neurons in the neural network. So these are the important parts of a neuron, which you can see. Now we are coming to the differentiation between neural network and digital computer. So we will discuss point by point. So digital computer uses deductive reasoning while neural network uses inductive reasoning. So what does it actually mean, deductive reasoning and inductive reasoning? Is that in neural network, in digital computer, uh, in digital computer, uh, generally we apply known rules to the input data so as to produce the desired output in case of deductive reasoning. But in case of neural network where we use inductive reasoning, we have given input and output data which we call as training examples. Means we have some pre-specified input and output data which are used to train the neural model, and then we construct the rules which can be used to decide the uh, decide the output of the future inputs, we can say. Then digital computers are centralized, synchronous, and performs serial computation. Means we have one a processor which is centrally controlled. It works with respect to time, that is, it is synchronous, and it performs serial computation unless we have in a computer a parallel computation architecture. Then in case of neural network, it is collective, or you can say distributed, asynchronous, and parallel. Means it is not centrally controlled, but since neurons, among the neurons, the task is distributed, so we can say that this is decentralized or distributed. It does not work with respect to time, and it performs parallel computation. As I have already discussed, that these neurons works simultaneously to solve a particular problems. That's the reason effectively why neural networks sometimes in a certain application performs much faster than the conventional digital computers. Then the connectivity among the elements of digital computer is static. Means at the time of manufacturing, the connections between the components or different units has been established, which generally do not change. But in case of neural networks, the connectivity is dynamic. Means we exactly do not have the idea how the neurons are connected to each other, and for different applications the different neurons may be connected differently. Digital computers, the results produced by digital computers are exact, and on the other hand, the results obtained or produced by neural networks are inexact, or you can say approximated results. Digital computers are applicable over well defined rules with precise input data. Means we need to write explicit programs in order to perform any specific task, any function. We need to write a specific program, which is of course a set of rules, and need to give precise input data. But in case of neural networks, we do not require the precise input or precise defined rules. It can work over complicated rules and can also accept noisy or partial data, because it keeps on learning. The different thing in neural networks is that in neural networks the important process is of learning process. So generally the rules, the inputs and the outputs are used for the learning process, and on the basis of those rules we can obtain the outputs of the future inputs. Now you can see the cycle time of digital computers can be measured in nanoseconds, and the cycle time of neural network, the neurons, is represented in milliseconds, and we all know that nanosecond means raised to the power of minus 9, and milliseconds is raised to the power of minus 3. So we can say of course that the speed of digital computers, the gates of digital computers, is much faster than the neural network. But still in certain applications neural networks perform better than the digital computers because of their simultaneous working characteristic. Now we need to consider how neural networks can help. So we have certain applications in computer science, not in computer science, but we can say in the real world scenario, where with the help of computer science the neural networks can be transformed into artificial neural networks and perform those applications. So those applications can be the classification, means if we want to classify certain things out of a particular heap, then we can use the concept of neural networks, because human brain is good at that rather than a digital computer. Recognition and identification, as we have already considered in the example. Suppose if we want to recognize something or a person, then in such cases the neural networks would perform better than the conventional digital computer. Assessment, if we want to assess a certain condition, means what is the exact state of a machine, like that, then we can apply the concept of neural networks. And forecasting or prediction, as we know that human brain can forecast or predict. Let's consider the example of the forecasting or prediction of rain. After viewing the clouds or the sky, we can predict whether it is going to rain or not. If it is cloudy, then we can say that yes, it may rain in an hour of two, in an hour or two. And if it is shiny, then we can say no, it is not going to be raining very soon. So in such cases, the if we want our computers or our machines to perform similar to humans, or to make them artificially intelligent, then we can say neural networks has a vast scope of applications. In the next video, we will discuss about the concept of artificial neural networks, how they can be implemented, and how they can be used. So this is all about this video. Hope you liked it. Thank you.